Whether it's the cap on a disposable water bottle or a life-saving medical device, behind every injection molded plastic part is a precisely engineered injection mold. Designing and building these tools isn't just a simple step on the way to manufacturing, it's the foundation of reliable and repeatable manufacturing. Mistakes in the tooling stage can be costly down the line. So today let's break down the basics of how injection molds are designed and built, why this step is so crucial for the long-term success of a program, and whether or not a mold is worth that high upfront investment, including how to choose the right tooling partner on your next project. In case you're brand new to this world of injection molding, let's quickly clarify what an injection mold is. Simply put, it's the block of metal that shapes molten plastic into a finished component. But if you've seen any of our previous videos on this topic, then you know that it's a bit more complicated than that. And the process of designing and building an injection mold, also known as a tool, involves several key steps, from design for manufacturing, or DFM, the mold build itself, and a number of quality certification tests before the mold is producing finished plastic parts. If you'd like to dive deeper into Crescent's full project management process, then be sure to check out our dedicated project management video here. But every decision made during tooling will impact part quality, cycle time, and total cost of ownership, which we'll discuss more in a minute. But some of the most crucial factors to consider during this stage are choosing the right material for your mold, whether that be hardened steel, pre-hardened steel, or aluminum, depending on the expected volume, resin type, and the required tool life. Aluminum, for example, may be cheaper up front, but this is not a fully hardened production quality tool, meaning it won't hold up well over time, which could lead to higher cost in the future. Running predictive mold simulation software also helps avoid costly mistakes by simulating plastic flow, cooling, and shrinkage before machining even begins. We'll also need to decide between hot runner and cold runner systems, which is another balance of efficiency when it comes to manufacturing and tooling investment. Determining exactly where the mold opens, known as the parting line, and how gases escape during injection is another key consideration during this design stage. And lastly, the cooling and ejection systems and designs are just as important as the design of the part itself. Water-cooled or oil-heated systems ensure proper temperature control during the manufacturing process, which again have quality, cycle time, and cost impacts down the line. Each of these decisions needs to be carefully made to achieve both a quality part at scale while keeping the total cost of ownership in mind as well. Speaking of which, there's no denying that tooling is a significant upfront investment. But it's crucial to look at that total cost of ownership, since cutting corners now could lead to higher costs in the future. As I said, a well-designed tool reduces cycle time, minimizes scrap, and lowers the cost per part over the life of the program. Preventative maintenance and support are also key considerations, as they can extend a tool's life and reduce downtime. So when viewed in this way, tooling isn't just an expense, it really is an investment in the future manufacturing process. But is it worth that upfront investment? Well, unsurprisingly, as an injection molder and tool builder, our short answer is yes, especially for highly regulated industries like medical, pharmaceutical, dental, and defense. But it's also our job as a tooling and molding partner to ensure that our customers are getting as high of a return as possible on that investment, and not needlessly spending their budget on a tool that has features and capabilities that are simply unnecessary for their manufacturing requirements. That said, in the markets I just mentioned, consistency, compliance, and traceability are non-negotiables. A poorly designed tool can lead to defects, higher scrap rates, and regulatory setbacks, while a carefully engineered tool lays the groundwork for faster cycle times, consistent quality across millions of parts, and easier validation and compliance documentation. So, looking at the entire life cycle of a program, the upfront tooling investment typically pays for itself many times over when managed correctly. Now, that all sounds great in theory, but let's look at an orthopedic surgical device that Crescent supported recently. This device required 13 different components, each with its own tight tolerances and assembly requirements. So before steel was ever cut, Crescent's engineers ran mold flow simulation to identify potential risks and carefully guided this customer through each of those decisions that we discussed before building 5 custom tools to manufacture the required parts as efficiently as possible. Once tooled, these parts were sampled and validated, then full production was launched inside Crescent's ISO 24/7 clean room to meet this customer's strict regulatory requirements. The result of that upfront investment: reliable tools, optimized total cost of ownership, and consistent part quality, all of which ensured the success of the program. We'll leave a link down below to the full case study if you want to learn more, but this is just one example of how crucial it is to get tooling right the first time. So at first glance, an injection mold may just look like the first step towards making a plastic part, but in reality, it's the foundation for the entire manufacturing process. From project kickoff to production, every decision matters, and that's why having an experienced injection molder like Crescent Industries in your corner is crucial for the long-term success of your program. So if you have any questions, be sure to reach out to us using the contact information down below and learn how we can help bring your injection molded part to life.